हेलो एवरीवन, वेलकम बैक। आज इस वीडियो में मैं दिखाने वाला हूँ पॉइंटर कास्टिंग कैसे होती है और उसको समझने के लिए एक बहुत ही इम्पोर्टेंट कॉन्सेप्ट जो कि है लिटिल एंडियन नोटेशन, और कैसे डेटा को स्टोर किया जाता है मेमोरी के अंदर, कैसे उसको फैच किया जाता है, वो सब देखेंगे इस वीडियो के अंदर। सो लेट अस स्टार्ट विद बेसिक एग्जांपल। पहले मैं डेमोन्स्ट्रेट करता हूँ क्या करने वाले हैं, फिर उसकी अंडरलाइन प्रिंसिपल्स को समझेंगे। एंड आई विल स्टार्ट विद द मेन फंक्शन and let us say we have int n and 345, some random value, and I'm making character pointer. Okay, so I'll give it the address of my number. Okay, now character pointer is pointing to an integer value, right? Now let me just do a printf of %c, and I am willing to print the value pointed by ch. So here I am doing dereferencing of the pointer and I am printing the character value % there. Let me compile it and execute it. You see why print हो रहा है, right? We saved 345 and y is getting printed. Why is that so? To understand this, let's switch to the whiteboard. Okay, so now the number I have is 345, which is being stored in an integer. Okay, तो ये स्टोरेज होता कैसे है वो बहुत इम्पोर्टेंट है। तो फर्स्ट एंड फॉरमोस्ट तो कंप्यूटर सारा बाइनरी में स्टोर करता है, तो 345 को पहले बाइनरी में कन्वर्ट करते हैं। ठीक है, 2 से डिवाइड किया, रिमाइंडर आएगा 1 और वैल्यू आएगी मेरे ख्याल से एंड वी विल राइट दिस नंबर्स फ्रॉम टॉप टू बॉटम। ठीक है, यही प्रोसेस होता है। तो मेरे पास नंबर आ गया 1। दिस नंबर इन बाइनरी इज इक्विवेलेंट टू 345 विद बेस 10। ठीक है, इसी वैल्यू को वेरीफाई भी कर सकते हैं। कैलकुलेटर मैंने ओपन किया, डेसिमल वाले सिस्टम में हूँ मैं, और ये नीचे मेरे को बाइनरी में दिखा रहा है। लेट मी डू flip the last bit, then I leave 2, then flip 2, then 0, then 1, then 0, then 1 और 345। ठीक है, तो ये है इसका बाइनरी इक्विवेलेंट। ओके, नाउ कितने बिट्स हैं इसके अंदर? 1 2 3 4 5 6 7 8 9, टोटल 9 बिट्स में हो गया अपना काम। बट इंटीजर स्टोर्ड इन 4 बिट्स, तो अभी बाकी प्लेसेस पे क्या जाएगा? माई बैड, 4 बाइट्स, दैट मीन्स 32 बिट्स। ठीक है, तो 9 बिट्स में तो अपने पास ये वैल्यूज़ आ गए, और बचे हुए जो 23 बिट्स है वो सब होंगे 0। 1 2 3 4 5 6 7 8, ये मेरे 32 बिट्स हैं। इसमें से 9 लीस्ट सिग्निफिकेंट बिट्स तो हमारे पास ये रहे और बाकी सारे रहेंगे 0। तो मैं उनको चेंज कर देता हूँ और बाकी सबको रखता हूँ ऐसे ही। ठीक है जी, ये हो गया मेरा 345। नाउ द इम्पोर्टेंट पॉइंट इज़ कि इसको स्टोर कैसे करता है कंप्यूटर, राइट? ये होगी मेरी मोस्ट सिग्निफिकेंट बाइट और ये होगी लीस्ट सिग्निफिकेंट बाइट। तो देयर इज़ अ नोटेशन कॉल्ड लिटिल एंडियन नोटेशन। ठीक है भाई, इसमें क्या होता है? द लीस्ट सिग्निफिकेंट बाइट गोज टू द हाईएस्ट एड्रेस, or we can say the most significant byte goes to the lowest address in memory when storing. ठीक है. So how will this be actually stored? It will be stored, the LSB will come in the front. This whole thing is having some address. So base address of, now this is one complete integer. This is my integer n. Okay, and let us say that address of n is 1000. Okay, for time being let us assume the address is 1000. So that 1000 is address of first byte. तो ये जो फर्स्ट बाइट है इसका एड्रेस है 1000. So what will be the address of next byte? Next byte will be located at 1001. Next byte will be located at 1002. और इसकी जो लास्ट बाइट है वो होगी at 1003. Correct? So integer n spans 4 bytes. Now when I do a character pointer assign the address of n, then what's happening is there is some pointer somewhere, let us say. Okay, this is my character pointer ch. I ask it to point to 1000. तो ये यहाँ पॉइंट कर रहा है, बट व्हेन आई dereference it, printf, I want to print the value stored in ch. Now what is the type of ch? Ch is character type. What does that mean? That go to that location and fetch as many bytes as your data type. So ch का data type है char, so it will fetch only 1 byte. Okay, this 1 byte will be fetched. Okay, and what is this? What is this? Let us open our calculator and check. It is 89. Okay, तो जो डेसिमल इक्विवेलेंट है जो स्टोर्ड है यहाँ पे वो है 89, राइट. पर स्क्रीन पे क्या प्रिंट हो रहा था? वाई. बिकॉज इफ यू लुक एट इट एंड आई विल ट्राई टू मेक इट मोर क्लियर. यहाँ पे अब देखो y का डेसिमल इक्विवेलेंट 89 है, राइट. Decimal equivalent of y is 89. So it is fetching that stored data, treating that as a character. So y's equivalent is that thing. जो sequence of ones and zeros है वो C programming के लिए y लिखने के बराबर है. Okay. So this is it about storage लिटिल एंडियननेस. थोड़ा सा आइडिया देने के लिए. नाउ ch इज सिंगल बाइट, कैरेक्टर इज सिंगल बाइट. लेट अस लुक एट अनदर कोड एंड ट्राई टू अंडरस्टैंड व्हाट इज गोइंग ऑन देयर. विद दिस वी हैव अ फेयर आइडिया ऑफ हाउ इज द स्टोरेज हैपनिंग, हाउ इज डीरेफरेंसिंग हैपनिंग. अभी एक दूसरा एग्जांपल देखते हैं. वी कैन सी दैट वी हैव अ बफर and it is a pointer which is holding the starting address for 4 contiguously reserved bytes. Okay, then I have a pointer I which is pointing to the starting address of this buffer, which is called the base address. The address of first byte is called base address. And then there is a short pointer s which is also pointing to the same buffer. That means s is also holding the base address of buff, I is also holding the base address of buff. Then I did s at 0 assign 0, s at 1 assign 1, and then I'm printing the value by dereferencing I is an integer pointer, whereas s was a short pointer. I placed two values. I had 4 locations. In those 4 locations I placed two values, 0 and 1, and I am dereferencing. So let us see what happens. Okay, so I'll just compile this code and execute for you, and see the result turns out to be 65536. Now how is it happening? So for that, let us move to the whiteboard, and I have already taken a screenshot of this code. The first line, okay, is represented here, and I am assuming the starting address to be 1000. So since stack is growing downwards, so 1000, 999, 998, 997, 4 contiguous bytes are reserved. Thereafter, I have an integer pointer. This is my integer pointer, and I store the address, the base address of this buffer here, so that is 1000, which is essentially means that it will start pointing to this location. The same I am doing with a short pointer. The short pointer is also pointing to the same buffer. Now I did s at 0 assign 0. This is very important to understand that how will this thing work, right? So for this to understand, let us resolve the right hand side of assignment first. We know that all the values get stored as binary. So first let us convert 0 to the binary equivalent, which is obviously all zeros. But how many bytes? A short takes 2 bytes to store a data. So 0 will be stored as, this is 1 byte and second byte. So this is the least significant byte of the value with which this short is going to store, and this is the most significant byte. Now where is it being stored? S at 0. Let us understand what does S of 0 means. So S of X, okay, array subscript. This means that we are trying to dereference or access somehow the address of S, which is the base address, minus size of data type of S. In this case we have short, so data type size is 2, multiplied by X. So using this I can jump to any address in my array, correct? So S of 0 is nothing but the base address, which is 1000, and short will consume 2 bytes. So if I give any address, let us say 998, if a short starts from here, then it will span up till here. It will span the 2 bytes. But in our case, the short is starting from 1000, so it will span these 2 bytes. So this value, which is 0, is going to be stored in these 2 bytes in little endian format. That means the least significant byte will be stored at the higher address, and the most significant byte will be stored at the lower address. So let's do that. This is the least significant byte. It will get stored at the higher address, and this is the most significant byte. It will be stored at a lower address. So that is about S of 0. Now what about S of 1? So we'll do the calculation again, and S of 1 will be which address? The base address minus size of the data type of S multiplied by 1. Okay, so that will be 1000 minus size of a short is 2 times 1, which gives me 998. So S of 1 is starting from this address, and since it is a short, so it will span 2 bytes. So the data will be stored in these 2 bytes. What is the data? It's 1, right here. It's a 1. So let us convert 1 into binary because we want to store it, and surprise surprise, binary of 1 will be 1. But we are supposed to keep this thing in 16 bits, so except the last, all bits will be 0. Now this is the least significant byte, this is the most significant byte. The least significant byte will go at a higher address, so this thing will go at the higher address, and the most significant byte will be stored at a lower address. Fine. So this is about the storage portion. This is how the storage will happen. Now, how do we get 65536 as the result? So look at this statement, printf statement here. In printf, I am dereferencing the pointer I. So in dereferencing, the pointer's data type comes into picture. In storing, pointer's data type comes into picture, because the data type tells us how many bytes from the starting address is this variable able to access. So an integer pointer can access 4 bytes from its starting address. So I am dereferencing I is at 1000, so it will be able to access all these 4 bytes. All these 4 bytes will be dereferenced by dereferencing I, because I is an integer and it will access these 4 bytes. So now let us see how will it access. Okay. Now the computer is storing data in little endian format. So when it will retrieve data, it will again undo that operation of storing. It knows that while storing I flipped the things, so I need to flip them back. So the fetching also happens in the little endian format. The byte which is at lowest address is fetched first, and the byte which is at highest address is fetched last, and then the whole data is converted to the data type. In this case it is an integer. So what will happen, this data which is at byte 997 will be fetched first, then this data will be fetched, then this data will be fetched, and in the last this data will be fetched. Now the data which is fetched is in binary format, okay, and the computer will now convert it into decimal because we want the percentage D representation. So let's go ahead and do that. So I'll get rid of this. It is in binary, so converting this to decimal. For that, what will I do? I'll open my calculator and see 8, 16. Number 17. 17 means 16th bit we need to flip. So let me just flip that and I get 65536. So this turns out to be 65536. That is why we are getting the result. Okay, so that's it for this video. I'll recap everything which I have told in form of points. The first point is data is stored and fetched in little endian format. Second point, the data type of pointer determines how many bytes it can fetch. So data type of pointer determines how many bytes it can store to, and again reminding you this storage will happen in little endian format. So yeah, that's it about this video. This is the recap, and because of these 2 points I don't want you to use mismatching data types of pointer and data. Make sure that you are consistent with the data type of pointers. You can leave your doubts, comments and discussions in the comment section down below. And yeah, that will be pretty much it. Until next time, peace.